Hi, in this video I'm going to talk about how to solve motion capture data onto a skeleton in Autodesk Maya. I'm going to cover the basics of the differences between global optimization and inverse kinematics to start off with, and then I'm going to show a pretty simple setup to get you started and using PeelSolve. You can download PeelSolve from mocap.ca. You can download it from here. There's a tools free and light version. If you just download this version here, it'll run the light version, which will get you solving. And if you like it, you can purchase it by clicking on Buy Now. So the first stage is to load the plugin. So if you go Windows, Settings, Preferences, Plugin Manager, you can go to PeelSolve 2015. Here you click on the checkbox here, and then you can that will load the plugin once it's installed. So the next stage is to import the data. So you can go to File, Import, and find the mocap data. It will load C3D or TRC data, which are common mocap formats. So I'm just going to load a range of motion here, select the C3D. You can drop down, go Peel C3D, select the data type as Peel C3D, and there's some options in here. Okay, so we import the C3D file. That will take a few seconds to do that. Okay, and then once it's loaded in, you can see the mocap data here as translation curves on each of those nodes. So the mocap data goes through its range of motion there. So we're just going to cover a really simple example. I'm just going to solve for one leg first as an example. So we need to bring in a model. Now we're going to go File, Import, and then we're going to load this character in here. This is a Maya file. I'm going to import that. And then the first thing is we have to pose it up. So we're going to select the hips and pose it inside of the data in here. Okay, so we're just going to fairly roughly do it for the purpose of the example. You do want to be fairly accurate with doing this. It will really affect the solve how well you get this posed. So if you get a good T-pose from the subject during the shoot, it will help quite a bit. So we can select that there. Okay, so I'm just going to solve for one leg first, just to give an example of how this will work, and then we can go from there. So show polygons here. The process is to select the markers and then attach it to the joint, and that will attach these markers to there. But just before we do that, I'm just going to cover a little bit about the basics between global optimization and inverse kinematics. If we were to take this joint here and go to Skeleton IK Handle Tool and select the first node, then select the last node here. You could, if you were so inclined, to... There we go. Okay, so we got an IK handle there. You could think to yourself, well, why don't I turn these 3 nodes into your rigid body and then constrain the IK handle, and then the same for the hips. Turn these 4 markers into a rigid body and use that to drive the route. But that doesn't work very well. The reason being is some inherent flaws with how inverse kinematics works. The problem with the IK is that the biggest problem is that when you get near full extension, it works fine when the legs kind of bent properly, but when you get near to full extension, very small movements. So if I move here just by like a couple of pixels, it creates pretty big movements in the knee. So small little twitches in the ankle can create fairly large movements in the knee. So to get around that, you have to keep the knee bent all the time, and it makes your character look like they're constipated, basically. Makes them walk around with their knees bent all the time, and it looks a little odd. It's not very natural, and there's no solve for beyond full extension. If the marker goes further than the effector, the effector goes further than the length of the joint, the leg just goes straight, and then when it comes back again, it pops out. So you get this kind of popping action, which is a pretty ugly artifact. So really you want to avoid IK where possible when using motion capture data. So what we're going to do instead is we're going to use the PeelSolve's global optimization solver in order to solve this leg. So firstly, I'm going to select the root markers. You first select the markers you want to assign, so I'm selecting those ones there, and then you select the joint that they're going to drive. So you select those 3 markers and then select the joint, and then you hit position on it. So the position constraint says match these based on the positions. It's going to try and figure out well, let's just run that. Let's just have a look at how that one looks. So this is the movement here. It's not too detailed in the hips, but we will give it a go. Quick trick here is to turn off we haven't set the hips. So we have to select the root, hit the set transform root, and then add, and that will tell it where to start the solve from, and then hit run. It runs it as a simulation at the moment. I'm looking at making a new version that will do it more interactively, but at the moment you have to pre-solve it and then play it back. So now what you can see is what it did for the solve was it tried to figure out the position. It moved the root around. It added, let's have a look. Animation graph editor. It added translation and rotation keys on the root in order to try to fit these markers to their target. So it tried to reduce the distance between this marker, which is a local definition to the root, and this global marker, which is a global motion capture position. So it did a fitting between those two. So it did a pretty good job of figuring out where the root is supposed to go. So now we're going to extend that out to the leg. So we're going to take these 2 markers here, add that one in, and then go position. What it will now do is I will, just so you can see it playing back, so I'm going to do edit, keys, delete, delete by type, channels, hierarchy below, apply. Okay, so because it won't show you it playing back if you don't have the keys turned off, just the way Maya works. So I'm going to run this now. It's going to play as we go. So what it's doing is it's per frame, it's calculating the rotation that's needed for this joint in order to match these together, as well as the translation and rotation for the root. So you should see as the leg moves around that it's trying to fit those markers into their targets on a per frame basis, going through each of the frames and figuring out an orientation for the hips. We'll probably see a lot more when we get to the leg point, if there is a leg point in this. Probably isn't. Well, hopefully you get the idea. Let's maybe should we do an arm? Would that help? Solve for an arm here. So I'm just going to lock these joints here. Lock, because I don't want to solve for them at the moment. Any channels that are locked will not get solved. They'll just stay as they are. Otherwise, we're going to get some pretty funky things going on without definitions there. So we're going to lock that one. So what we'll do is we'll solve for these markers here to drive that joint. So just like that, the root, delete by type, channels. Okay, so I'm going to run this again. This should be a bit of a better example. Okay, so what you can see here is it's figuring out the rotation of the joints in order to make those markers meet. I didn't lock the very lowest joint here, so you can see some bending down there, but you can see the action of how it's fitting the 2 of those together. I think that kind of explains it to some degree. So I'm just going to cancel that. Okay, so so we're going to do that for the rest of the body. We're going to basically match all of these up. So we need to zero that one. Oh, let's delete the animation first. Edit, delete by type, channels, and then select that, zero it off, and then lock selected. Okay, so we're going to select these three markers here and use them to drive the chest. So matching on position there. So each time I'm clicking the markers that I want to use to drive the joint, and then the joint that they're going to drive last, and then I'm using the position constraint in order to create the attachment between the two of them there. So, boom, boom, boom. Just going to put a pretty rough. You'll want to spend some time to match the joints up to their targets pretty well. It is important to get that initial setting fairly accurate. So these three markers I'm going to put into the hand. Bit of an offset there, that might be a problem. So I'm going to go there and then pose that one back. This one here, I want it to snap it back, so I'm going to use the exclamation mark here. That will force it back to its original position. These three markers I'm going to use to drive the hand. And then these two here I'm going to use to drive the elbow. Now the elbow as well, I want to make it a 1 degree of freedom. I'm going to make it, I'm going to lock that, and then I'm going to lock that. Same on this one. Lock, and then lock. Okay. So I'm also going to go here, select these two markers, and use that to drive the elbow, because I don't have anything driving the elbow right now. And then did I lock some channels here before? So we need to drive something to drive. Every joint should be driven by a marker. If it doesn't get driven by a marker, it'll be free to float around and you'll get some weird artifacts from it. So it needs some kind of a definition. Alternatively, you can use stiffness, which I will likely cover in the next video. Okay, so we need some kind of a definition for each one of those. I'm using the chest for that one, using those markers, the other leg, selecting the joint and then the thing that's driving them. Oops, don't have that foot in place. Gotta fix that. Okay, and then zero that one in, zero that one in. Now for the feet, I'm going to select these three here. I'm going to use that to drive the foot. I could use 4 of them, but I think these 3 should be fine. Toe, foot, marker 42. I don't need that one. That one is no use. Let's get rid of that. That one to drive the foot, and then you can use the ankle to drive the knee if you want. You only really need one for the knee, especially if it's a hinge joint. Okay, so there we go. We've got them all set up. We've got them attached. Now the head we've got to finish off doing. So that's the neck. We're going to attach these 3 here to the head. Pow. And then we're going to, for the neck, we've got to give something for the neck because we don't want the neck just to wobble around. So I'm going to use these 3 at the back here. But I also want to give it some kind of vector for the head. So I'm going to use this one here as well, because that will give it partly shoulder and partly kind of blend between those two. Okay, so now we've deleted the animation. Now let's give that, we've set all the relationships between them, so let's give that a solve. So what you're seeing now is it's going to go through and per frame figure out the orientation of all of those joints. Oh, I missed something. Here we go. Let's unlock those ones. Unlock. Unlock. Did I unlock anything else? Unlock. These. Oh, that one I'm going to leave locked because I don't need that one to rotate because that will follow the hips. I'm going to let the clavicles. Did I define the clavicles? Don't think I did. So we will. Oh yeah, there we go. So that marker there. Oh, that one goes into the left shoulder, so that's okay. So, and that one there goes into the left shoulder. Okay, so let's give that a go. Let's delete the animation. The reason I delete the animation, so edit keys, delete by type channels. Okay, you don't want to make sure you don't do delete all by type channels because that will delete Mocap as well. Make sure we keep those keys. Okay, so we're going to rewind that. So the reason we delete the animation is so when we hit the solve, it will show us the playback. Otherwise, Maya will go to the next frame, update the display, run the solve, and then go to the next frame. So what you're actually looking at is the old animation. It doesn't update it and then run the solve. Oh, sorry, run the solve and then update the display. It's not the way it does its simulations. So you can see it running through here. Each of the frames are, on each frame it's calculating the orientations for the joints in order to close the gaps between the markers and the targets. And the beauty of this is it allows for hyperextension, it allows for targets moving beyond their limit, so beyond if they go fully straight. All of that is fairly intuitively mapped, and you won't get any popping in and out of film. Well, certainly a lot less if you do get any, but you shouldn't get any popping in and out with a good mapping. This works best when you're mapping directly from the original capture subject proportions to a model that's the same proportions. If you need to do a large amount of retargeting, so if you're mapping from a skeleton, from a regular human skeleton onto a dwarf or a troll or something that's disproportionate, then what you should do is first solve onto a matching skeleton using this process here, and then use Maya's human IK to human IK to do a retarget between the fidelity solve and the one that you're needing to solve onto. So it's just about done. This is a very quick first pass. I haven't even been looking at the model in here, and there's definitely some kind of an offset for the wrists here. But we'll, gives you an idea about the basics of how the solver works, and we'll have a look at how that plays back on the actual model. Just as a very kind of rough first pass. Do you want the hands to match up? These hand markers were on the actual hands themselves, so there's an offset there. So you should probably shorten the arms or something for that, because that's not going to work out so well. Okay, so we're seeing some kind of a, well, let's just have a quick scrub through. Generally it's showing the right performance. We're seeing some kind of a wobble on the spine. As the neck's coming around here, it's causing some kind of a artifact on the spine. So let's have a look at that. Let's see what's happening on here. So this spine joint here and this one here are twisting. The reason being is there's compression of the spine. These markers are pushing down the way and it's forcing this joint out. There's a couple of ways you can fix that. If you go to the attributes on the joint, so you select the joint here and then you click on attributes, you can turn on length degree of freedom. So what that will do is it will allow the joint to compress, and you'll also want length stiffness. So whenever you have length degree of freedom, you pretty much always want length stiffness. So we can set that one here as well. So let's just solve that range and just see if that helped. Also, if you have more markers, usually I recommend having a ladder of markers. So one here, one there, and one there. I highly recommend having those extra markers on the back will give you a much better solve for the spine. Also enabling length degree of freedom as well. I'll cover stiffness and degrees of freedoms and some of the more these are pro features. If you just have the basic version, you may be fighting that with a little bit. You can fix that by just making the spine a bit shorter, or adjusting the way that the markers are defining, scaling the model. And in this case, the model is probably too big. I probably should have scaled the model down. So I scaled the scaled the model down or scaled the marker data up in order to compensate for that. But let's just find that little, you can see the spine moving so as the neck's compressing down. You can see how these are falling short of the top. These have come down the way, so these markers are trying to get to there, and it's doing it by pushing these down. So let's do edit keys. Keep doing that. Delete by type channels, and then resolve with length degree of freedom on the spine. Okay, there's definitely some compression of the neck, still causing a bit of an issue there, but it's lessened it, it's cleaned it up a bit. Let's try, just for argument's sake, let's just make the mocap data bigger. And that will, I mean, that's a pretty hacky way of doing it, but just for the purpose of illustration, delete by type channels. That should give the more space between the spine and less compression at the neck. So, and a better initialization pose will help for that as well. So, okay, it's a little better. Getting there. Well, we'll cover more advanced cleanup in another video. Let's just solve a bit of a wider frame range and then have a look at that playback. But generally, I think you get the idea. This is the process of attaching the mocap data by doing position constraints and solving it as a simulation using PeelSolve for Autodesk Maya. Something else was funky going on there. What was that all about? That's an unusual one. Oh. Stop doing it now. Just a glitch.